Our first presentation for this morning will be imparted by Mr. Joe Chan, Director, Cyber at KPMG Singapore. A little on Joe. He is the Director of Cybersecurity Consulting at KPMG Singapore and has a wealth of knowledge and experience in cybersecurity, having spent more than 20 years as a consultant to many businesses around the region. Joe has led cybersecurity risk assessments, architecture reviews, vulnerability assessments, and penetration testing engagements for over 23 critical infrastructure and industrial facilities, strengthening their security posture and their ability to defend against attackers. He will be presenting on the topic cyber risk assessment and threat modeling. Before we begin, a quick note that we will be utilizing the Mentimeter platform for this session's Q&A segment. If you wish to submit any questions to Joe, please visit menti.com and key in the code reflected on screen. Without further ado, please welcome Mr. Chan.
Hi, good morning. So if you're given a task to keep water in the pot at precisely 93 degrees, as close as possible, what would you do? The pot is on the stove and you're given a thermometer. So the likely thing that you'll do is this. You will turn the stove, the heat on the stove up and down, and you'll look at the thermometer every now and then decide whether you want to turn it up or turn it down later. So this basically will be something that you'll do in a rather panicky mode. In the past, operators in industrial plants generally do this or the same thing using push buttons to control actuators in plants. These could be pumps, tanks, valves, and so on. And at the same time, they'll be monitoring readings from sensors, and then they will decide what to do next. And that's basically something that plant operators from a very long time ago would do. Now, when the plant processes get more complex, if the process variables become much more than just one or two, you'll see that things get unmanageable. This is just crazy. So automation is generally the way to go, and what a lot of plants have put in place are these things called PLCs. And these are basically things that you can program in order to control the devices in the field and monitor the sensors and decide what to do. So this is basically replacing you or Bart Simpson in the whole process. This is basically a loop, and in engineering we call this a closed loop feedback process. Now, automation is used in all sorts of things. You see them in the ports and specialized terminals such as these. This one is a picture of a quayside crane, and you'll see all sorts of automation deployed. For example, the gantry, where the cranes basically move alongside the quay in order to be placed or positioned in the right place for ships and to unload and load cargo. If you're looking at the right-hand side of the crane, you see a trolley that will move, back and forth the bridge girdle, and also to lower the hoist in order to unload containers from the container ship. So that's automation used in ports and terminals. Automation is also used in propulsion systems on ships. This will be placed in the engine control systems, where some kind of interface can be used at the bridge, on the bridge, and then you can control the engine systems to some extent and regulate the engine that cranks the shaft that turns the propeller and in turn give propulsion to the ships. So this is automation in ships. Automation is also used in steering and navigation systems. And if you look at the bottom of the screen, you'll see rudders that basically steer the ship and its direction. And on top of that, you'll see the controllers that actually regulate its movements. Then on top, you'll see many screens that tell you where you are in the world, which direction you're going, and so on. But what I want to point out to you is, if you look at the bigger two arrows over there, you see connections. And the connections basically connect all this equipment via a particular network, or a wire, if you will. And one of them is an IT network. It's more obvious here compared to the other two, but you can see that IT systems appearing inside automation systems. Now, this one is slightly more advanced, and in recent years, because of the COVID pandemic, there is a large demand for vaccines. And the transportation of vaccines is a tricky one. You basically need a lot of temperature control and monitoring, and there's a lot of tracking and visibility that's required. So IoT has been placed into, as part of innovation, into that supply chain, and that sort of tells you whether things are, whether attention is needed for a particular container and so on. So this is IoT and a slightly more innovative piece of technology in the automation systems. Now, IT and OT basically converged. It's happened a long time ago, but it's going to continue to happen for a long time. And at the same time, while it gives you a lot of benefits, it also gives you some downsides as well. One of them is the exposure. So once you expose the automation systems or the industrial control systems, what you get is risk, and that we call attack surface. That's basically exposure to threats and all types of things. Now, don't read too much into the slide, but generally, if you have a cyber incident, it leads to generally two types of things. One that could be exerted by hackers alone, and these could result in things like a data breach. So basically, personal data being leaked out and so on. You could have disruptions over your IT systems or your OT systems as well. But the third category of risks generally are those that are related to physical impact. So this could lead to safety, loss of life and limb, damage to property, and so on. So just bear that in mind when we look at risks from a cyber perspective. It can start to cyber incidents, but it can end up with something more disastrous. So I'll go into the process of doing a risk assessment that we do quite a bit over our past few years. Now, this is a methodology from a local regulator in Singapore, and it's basically something not very unique. It's something that it has elements that most risk assessments would have, and generally, the talk is adapted towards that methodology. There are some unique parts to this method, basically the introduction of threat modeling in the whole process, which actually is a way to craft scenarios. The answers, in a very layman terms, these are the questions you are trying to answer in the risk assessment. What can happen? Generally, you could break that down into two things. How can someone get into the network, and what can they do inside? If you don't have controls in place, what's the worst thing that can happen? And we call this inherent risk. What controls are in place, existing controls in place to reduce the risk? And then if you take that into account, is that risk still very, very high? And then later on, if you don't like the level of risk that you have, you sort of need to do something else in order to lower the risk to an acceptable level. That's basically the questions you want to answer. The first thing you want to do is you identify the assets. And in order to do this, you need to, you will have some challenges. And one of those things is that you'll find in very old systems, you basically don't know what's inside. You don't have an inventory. It could be updated 10 years or 20 years ago. Things have been added and forgotten, and so on. So this is a challenge. So you might need to use a few things in order to get what you want, to know what's inside your systems. And this could be using physical count. You could actually trace cables. This is very difficult. You can still use your existing asset list. You can use some things like IT asset management, although I'll caution you on that. Or you can use some kind of specialized tools that are non-invasive in nature. Now, an architecture will help you. This is something that I've grabbed off the internet and sort of pieced it together. This is not an existing architecture of any ship and so on. But if you look at these two pieces of, or two parts of architecture, IACS categorized the network into two parts. It's generally the administrative part of the network, which is basically, the parts of the network where people use to do emailing, communications, and so on. So that's on the left-hand side. And there's also the network that I told you about that connects the OT systems and the things, the machinery, the equipment, and so on. So that's sort of the control system on the ship. Now, you might want to assemble a cross-functional team, and we have worked with lots of clients with great cross-functional teams. So they might consist of operators, engineers, finance people, IT folks, and cybersecurity people. So this is going to help you a lot. It's not going to be a single cybersecurity team. Now, don't forget the physical environment. I'll just quickly go through this. Now, if you compare that, a ship with a critical infrastructure, let's say oil and gas, things don't change so much in the plant compared to, let's say, a passenger ship. For one, passengers will go up the ship and then come down. There's lots of changes there. Crew change when you get to a port will also make the environment will change again. Maintenance people can come up and down the ship for maintenance, and sometimes for repairs you need to dry dock, and then you don't know who is going to be on the ship. So it's a much more dynamic environment on the ship compared to a critical infrastructure that's much more static. Now, if you look at the connections, let's say, of the equipment on the ship and the critical piece of infrastructure, in Singapore, most of the critical, the plants are actually disconnected from the internet. There's lots of guards there, and on a ship it's quite different. You need internet. It's for the passengers, it's for communications, and so on. You can't disconnect yourself from the internet. You have VoIP, emails are there, and so on. So how can an attacker actually get into the network? We'll discuss a few things over here, and they involve satellite comms, legacy systems, phishing is still part of the picture, USB thumb drives. These are all part and parcel of a ship. Satcoms are generally a bit like a cellular modem. You use a cellular modem when you are out in the where you are sort of in the remote area of the world where there's still some cellular comms available. But when you go out to sea, Satcoms is the only way that you can actually communicate back to the internet. And the internet is not in the sea, it's on land. Now, some of the things that if you read, VSAT web interfaces are the things that you actually configure the modems in order for you to actually get the connections. Most of the time you can see that, we'll show you later, that a lot of the VSAT modems are actually exposed on the internet. and the default passwords are not changed. And once in a while, you actually see some ports that deliver remote access also open to the internet as well. This is one that I've just captured a few days ago. And if you just look at VSAT, in this case, I looked at RDP. There's a few out there, VSAT modems that actually you could reach, and perhaps you can actually try to crack the password as well. This is just some of the ports that are open. And Shodan is basically something like Google, but you can search for devices. Sometimes you see power plants online and all sorts of things. Now, legacy systems, you might still find XP in certain plants or ships, Windows 7 as well. So these do provide or present certain risks to the environment that you're in. And a lot of times you ask why these things are still there, and generally it's because it might be a danger to change them, or it's difficult to change them at the same time. Phishing can still occur on a ship. Basically, there's still emails that go on inside the ship, and you might get a crew member or passenger that clicks on a malicious link. Now, USBs are generally used for upgrades on ships, and if the security measures are not so tight, if you share that USB around, you're going to get viruses or malware being spread around. And most of the incidents that are just reported involve the sharing of USBs at different ports, usually by maintenance people coming on board. So those few things. So next question is, what can they do inside the ship? Now, for one thing, controllers like this have a program inside, and they generally use that to control or regulate the machinery inside the ships. And if you actually tamper with these programs, you can get the ship into a lot of trouble. So that's one thing that can happen. And usually it involves a programming tool like the one that I'm showing you. Now, AIS is something quite interesting. IMO requires all ships operating in most seas to carry AIS. And there are two parts to this. There's a transmitter that actually takes feeds from the GPS antenna off your location, your heading, your speed, and so on. And that gets transmitted to the AIS BTS. So this is the base stations that you can see off the coast of the land. And that basically gives the information from the GPS to the AIS base stations. And the receiver, on the other hand, will actually receive that information, and that basically tells you where you are, where other vessels are in the world, and the purpose of this is generally to provide or enhance the safety at sea. Now, AIS also feeds into something called ECDIS, and this, together with lots of other inputs, including the electronic charts, the GPS antennas if it's external, the gyro compass gives you a more complete picture. It tells you where you are in the world, it tells you where you're heading, and so on. And that, in turn, controls the autopilot, and you might make navigational decisions based on the information that you get or presented by ECDIS. So this is the same information collected by AIS, but not presented on the ECDIS, which is a PC, by the way, on the ship, but on the internet, on a website. So if you, and this is one of them, and basically if you zoom in, you can actually tell where you are in the world, as well as the vessels that are around you. And that's basically what kind of things you can get from AIS. Now, if, let's say, someone tampers with parts of this data that gets fed into the ECDIS or used to decide how you're going to navigate, it's going to basically steer you off course, perhaps, or give you wrong information, and hence you might make the wrong decisions instead. So this is something that cyber attackers can do. Now let's bring all this or connect the dots together. And basically, this is where we were just now. We've got a few places where you could get into the ship, and you got a few things or hints or things that they could do on the ship itself. So this is sort of like the two ends of the path or the course of action. Now, what you could do is actually connect them by trying to find out what is in between and then trying to connect them together. This could include things like what we call lateral movements. And this is basically when the attacker jumps from one computer to another or across networks in order to reach their destinations where they want to affect any impact. So that's basically what you could do. That's just a nutshell. In actual fact, that's pretty technical. Now, and after that, you could verbalize that into words and put that into a register. That's basically what you see at the bottom. Now, this picture that you have is a bit funny because it doesn't tell you much context. It just tells you what could a hacker do, but what does it mean for your senior management? What does it mean to your organization? There's something missing. And basically, it's a bit of a, it's a bit narrow in terms of its context. And it's basically, if you're thinking like a hacker, or if you have, the only thing you have is a hammer, everything is a nail. So this tends to be slightly narrow, and if you've got a cross-functional team with you, they might be able to give you some kind of perspectives in what this thing is missing. So it's rather technical. I know what can happen, but what does it mean? Now, for one, hackers basically there's not a lot of things on the ship that's valuable to hackers alone. They might want to do ransomware on a ship, but what are you expecting the ship crew to actually pay you ransom, so on. Now, what's missing is the other threats. So, and what's the prize or what's the destination that you want? And so pirates are basically one of the menaces at sea. And if you actually don't need to look far for pirates. Actually, 40% of the piracy in the world happens in the Malacca Straits and Singapore Straits. So we've got lots of pirates in the region. Pirates also know what they want. Now, if you look at the top top types of ships that they attack, they've got bulk or general cargo carriers. They've got crude oil carriers as well, and they've got container ships. They know what they want. Some oil, high-value cargo includes oil, narcotics as well. Now let's think like a pirate instead, and we want to think like a pirate that has a hacking capabilities. Now, if you want to get the most out of your ROI as a pirate, what would you do? First thing, you might want to selectively target your ships, and that includes locating where they are in the world. Perhaps you don't want something that's near a law enforcement ship or some sort. You want to identify the cargo on the ship in order to better target what you want. You want to control the ship if you can, and you want to be able to steer the ship into places where it's easier to board and also away from law enforcement. And then once you get on the boat, you also want to find your cargo easily and extract it. So that's a bit like thinking like a pirate, but not quite like a traditional pirate. Now, AIS, I mentioned to you, is something public. You've got lots of information, and everyone can see it. And pirates can also locate other ships and their locations. In some parts of the world, you are allowed to switch off the AIS transmitter. So, for example, some high-risk seas. And that's because there are pirates over there. But this information is public, and it's a double-edged sword. So you can use AIS for that matter. If you are going off, the range of the AIS base stations, satellite systems also actually can transmit or ride that signal on top as well. Now, the other thing that you want to do is identify the cargo on the ship. You don't want to go after a fishing ship or boat. One of the things that you want to look at is the cargo manifest or the bills of lading. And there's a few places that you can find this. One of them is onboard systems, because the ship needs to have records of the exact cargo on the ship and where they are. The ports or specialized terminals might also have that information because they're expecting the cargo to be unloaded, loaded, and so on. Onshore shipping companies might also have this kind of information with them as well. So that there are several locations where this type of information is actually located. And if you are able to get into some of these systems, you'll be able to do all sorts of things. Cargo manifest and bills of lading are two different things, but one is more legal in nature, one is more logistics. Right now, if you go back to the things that we've just spoken about, why would I want to control the engine, right? Or why would I want to tamper with the navigation system? With this context, it might make more sense when a hacker wants to stop the engine, for example, or steer you off course. This will give context to the analysis that you just made. Now, when it comes to let's say a crude carrier, let's say a very large crude carrier, you get on board, the only thing that you have is crude oil. So that's simple. You just need to siphon that into a second vessel, and then off you go, bunkering at some place in the sea. But if you get into, let's say, general cargo or container ships, there's too many. This particular one has 13 bays, and it's pretty long. So you don't know what to get, and so on. So having that information on the exact location of the cargo and the nature of the cargo, let's say narcotics, would be very, very useful for pirates. Right? So other than piracy, there are a few more things that in the past, various criminal gangs have done. It's not just on things on the ship. They can also target terminals or ports. They can steal things from the ports as well in somewhat similar fashion. Now after that, you might want to think about, what is the impact of this kind of activities done by various threats. I've shown this particular one because it has all sorts of threats, or all the threats that you could imagine. This is an accident, not a cyber incident, but basically it does have that kind of worst case scenario that you can imagine. There were 11 firefighters died in this particular incident. This was 2001 off South America. The environmental impact was somewhat minimal. There was the wellheads were still intact. There was no oil spill, but there was some bit that still needs to be cleaned up. This thing sank after 5 days and a few explosions. The impact of operations, basically, they were losing 10 million per month afterwards. Financially, the whole thing was underwater, together with about 1,500 tons of crude oil underwater. Reputation-wise, you know what has happened. Now, this particular offshore oil rig is not planted onto the seabed. It actually floats on things that look like a catamaran. So that those two things at the bottom, two sides of pontoons are called pontoons, and they basically float on water. And one researcher said, if let's say you drained one side of the ballast, and this is sort of a ballast where you can actually suck in water, pump in water, and then or push out the water in order for you to have more buoyancy. If you drain that, the whole thing will list to one side, and basically that's what happened over here. So you can actually possibly hack into some of these and actually tamper with the control systems and make something very bad happen. If you've done some risk assessments before, you can put that into a matrix, and then this is just a fancy way of visualizing things. Now you might want to, after that, find out what you have existing. You could have awareness training. In this case, you might have changed your passwords. Make sure that you've updated the firmware on the satellite dishes and so on. So these are things that you could have in place. I'll just skip through this particular. This one is interesting. So lots of things happen through the USB. You could actually do things. You can actually insert the USB into something called a ship dip. And basically on the photo on the left-hand side, you see a ship dip. And basically that's basically a disinfectant. So the sheeps just jump in, disinfect themselves of bacteria or germs, and then they come out. And that's basically the idea of a USB scanning station. You pop it into the station, you scan it, you see if it's okay, and then you insert it into the actual computer that you want to upgrade. No, it's not alcohol. Segmentation is about this. So in short, let's say a burglar gets into your very big house. We don't have a lot of big houses in Singapore. And if they get into the kitchen, you just want them to stay in the kitchen and nowhere else. That's the idea around network segmentation. Then after that, you could actually just plot. If you sort of subjectively think where you are in terms of the risk, the current risk, you can plot that in a matrix like this. Then once you can compare that level of risk to what's acceptable to you as an organization, and decide whether you still need to do more in terms of additional controls in place. So that's in a nutshell a risk assessment done on a ship. It's not all the risks that you have on the ship. There's other things on the ship that you need to consider, that engineering risk and so on. But this are basically a risk that starts with cyber incidents and then end up with something more physical. Now, questions? What is the most? So I'll just answer some of the questions I have that I have here on the tablet. What's the most common vulnerabilities you see in the maritime sector? I've mentioned that in the presentation already. So you could satellite comms is one way to get into the ship. The corporate network is also one of the more popular ways of going from your corporate office into the ship or into the terminal as well. So that's another way. USB is another. Who should be responsible for collecting all this data, CISO or dedicated teams? So the question is, who should be responsible for the risk assessment and collecting data? You could have a cyber security team with the organization, and they can be the ones collecting data and helping you with the risk assessment. If there's a need to outsource or there's no capabilities in-house, then you might want to outsource it to another party. I'll just look through this and, there's 3 more questions only. So with so many different systems, how do you ensure interoperability and ensure cyber security? So So interoperability is not a problem that cybersecurity people try to solve. That's basically a problem for standards to solve. So for example, the use of, let's say, a particular communication protocol like NMEA 0183, that's something of a job of the standards people. How do we ensure cybersecurity? I think to a large extent you need to invest. You need to invest on priority things. And one of the things that the risk assessment is able to do for you is to help you identify your key risks. So if you have, if you know that the attacks actually start somewhere, and you might want to just address that issue first, because if no one is able to get into your system, for example, nothing can happen. So you might want to prioritize things that are more exposed to the internet or your corporate network. Right, next question. Since there's an increase in IT and OT convergence in the maritime industry, in your opinion, how would you impact the economy? Okay, so I don't think this is a cybersecurity question, but generally, the reason why you have OT and IT convergence is basically you want to reap the benefits of IT. And the benefits of IT generally come from connectivity, which is very different from the connection between electrical wires and machinery. It is much more richer, or is able to communicate much more richer data or carry it along. You are able to create more creative applications, and that drives competition between, let's say, terminals. It could distinguish your particular shipping service from others as well. So for example, if you are for the transportation of vaccines, not everyone that has a reefer container might provide the level of service that you want. All right? So I think generally that convergence is there, and that's basically going to drive efficiency and innovation. Does this mean moving ahead with e-bills of lading will carry a lot of cyber risks? If so, how do we counter this? So I guess, as I mentioned just now, the bills of lading or the cargo manifest could be considered something sensitive. It's useful for particular parties, and they can leverage it to do all sorts of things. Now, perhaps it could bear some cyber security risk, and you definitely want to protect that information. I mean, if let's say you've got a military vessel and is carrying something sensitive, you do not want someone to know what's inside. And that's basically the bills of lading and the cargo manifest. I got 7 minutes. How do we change the mentality of my system is not connected to the internet, so my ship won't be hacked? Now I sort of mentioned 3 ways that someone can get into the ship through unauthorized means. One of them is USB, basically that's something quite physical. Right? And you voluntarily actually allow someone to bring up this USB into your ship and actually plug it into your ECDIS and so on. So that's something that doesn't require the internet to transmit something harmful onto the ship. Now, I've mentioned piracy as one of the use cases for hacking, but there's others. One of them is actually smuggling. So there was a case in the early 2010s, and this happened in Europe. A bunch of drug dealers, basically smugglers, they basically sent a phishing email to a terminal. This is a major terminal in Europe. And basically, they also broke into the port and installed things such as keyloggers. So actually, they broke in the middle of the night and put in things called keyloggers. They basically are in between your keyboard and your PC. And they basically are able to sniff out your passwords or whatever you type onto the keyboard. They've done a few more things, and they've hid all these devices quite discreetly. When the authorities, the Europol actually, when they actually cracked the case, they found lots of devices inside power cords, or those power plug cords that are this big, and there were things hidden inside. So this is an example of, it's not just remotely hacking a system, it's actually someone else, a physical attack coupled with hacking. Now that particular case was quite interesting because what they did was they knew what the schedules of the ships, what was on the ships, and the time of unloading as well. And what they did was that they hid narcotics in the container and shipped it out. And when it got to the port, basically they knew it was unloading, and they arrived earlier than the actual the shipping or the truck that was supposed to receive the goods, and they took off with the container holding the narcotics. And on the way out, you have gates. Basically, the ports will not allow you to go out with the cargo without something. And they knew the operations quite well, and they knew that if you presented the bills of lading to the people there, and with a PIN, they will be able to, they will be released out of the port. And that was precisely what they did. Okay, so that's a bit on, without internet, what could you do? All right, so the next question is, so far the shipping industry is the shipping industry receptive to cybersecurity defense? Is it proactive or reactive? Now I can't tell for the whole of the shipping industry, but those who have engaged us, KPMG, to do our work, they've been quite proactive in their measures. They are quite forward-thinking. So I guess that's basically a mixed answer. There are many third-party systems sending data to different vendors. Example, fuel consumption monitoring, engineering monitoring, and so on. For this, how do we consider this external network risk in the risk assessment? Yes, so if you look at the architecture that I just sort of showed you just now, the ships ourselves are highly connected. And it's connected to multiple parties. One of them is the shipping line, where they're constantly in contact. The others could be the companies that are actually shipping the cargo itself. And they might have, they might monitor the cargo itself, like I mentioned just now as well, such as the reefer containers. Some of them might be maintenance people that are monitoring the engines, and that telemetry is constantly actually going out to the internet. So the kinds of measures that you want in place are, you just want to restrict that connection between those parties that you want to know, to have that data. That's basically what you do. And the last question is, in your opinion, was the Ever Given hacked? Answer is I don't know. All right. Any more questions? I've got 1 minute left. If not, thank you very much.
Thank you, Mr. Chan, for your insightful presentation.